For the next video, we're going to take a look at some questions from 25 to 31. And 25 to 30 all kind of fit the same form. I know there's different variations, but the idea is there's always a variable that's in the exponent, and there's only a variable in one of the exponents. So we have two options, two different ways to solve this, and even with those two, there's probably other little variations through that. But when we have just a variable in one of the exponents, not in more than one exponent, it's most helpful to isolate so similar to when we did radicals, we want to isolate the exponential. So for 25, that means we're going to add 5 to both sides. So this one would be 2 to the b equals, adding 5 to both sides gives us 13. For number 26, I know we didn't finish 25 yet. For number 26, we would divide both sides by negative 8.5 to get the exponential by itself. For 27 and 28 and 29, the exponential is already by itself, so you don't have to do that step. It's already isolated. But once we do that, we still have a couple options. And I will show you both options for number 25. I'm going to erase this and make it a little smaller just so I don't run out of room. Remember, I added 5 to both sides. So 2 to the b equals 13. And option 1, we can write this in log form. So it's in exponential form. There's a variable in the exponent, and that's kind of the problem issue, that we have a variable in the exponent, so we don't want it there. So one option is just to change this to log form. So remember, that would make it log. The base of the exponent is exponential is 2, so that's the base of the logarithm. So log base 2 of 13 is equal to b. Now this is like a problem we did a few sections ago. We don't have a log base 2 on our calculator, but we can use the change of base formula. So change of base, which really is, we're going to put the log base 10, which we don't write the 10, of 13 over the log of 2. So 13 and 2 came from here, and we chose to use log base 10, although we don't write that in because it's understood, equals b. And now we can type that in our calculators. So we want the log of 13 and divided by the log of 2. Now, before I hit enter, I want you to think through something. I should have mentioned this before, but all the way up here, this is 2 to some power equals 13. We should be able to give a good estimate of what that would be, because we know that 2 cubed is equal to 8, and 2 to the 4th is 16. So somewhere between 3 and 4 is going to give us this answer. So now I will hit enter, and you will see that it is 3.7. It says round to the nearest 10,000th, so actually we're going to put 3.7004. That's the 10,000th place. So that is B. I should have written that down here because I'm doing another option here for how to solve this. So we'll erase, and then we'll do option 2 here, and you guys can choose which you prefer. Option 2 is going to be the way that we have to solve other ones that are a little more complicated, but option 1 is a simpler way in this case. So option 2, we still isolated the exponential, but what we'll do now, so we have 2 to the b equals 13, we actually just take the log of both sides. Just like in other math problems, we would take the square root of both sides, or add 7 to both sides, or take the inverse sign of both sides. We can take the log of both sides. The reason we do that is we can use that power rule that moves this out front. So this is going to be b times the log of 2 equals the log of 13. For right now, we're going to go ahead and just change our different logarithms to decimals. You can work with it in log form, but we're not going to in this case, so we're going to type in log of 2. So we have b times 0.3010 equals log of 13. We got 1.1139, divide both sides by the 0.3010. And we get, so 1.1139 divided by 0.3010 gives us 3.7007, which is not the same as this. It's very close and it's not the same. The reason it's not the same is because we did rounding early on. We rounded here, and once we have a rounded answer and you do work with a rounded answer, it's going to make it a little bit off. So I will accept this answer, obviously, but that's why, because we rounded. Let's go ahead and look at, let's do 29. So I think I made a mistake about 29 before. I didn't see this -8 out here to start with. So it is not just an exponent equals a number. So we still have to isolate the exponential first. We would do that by dividing both sides by -8. And that would give us 4 to the -4x equals, let's do 38 divided by 8. I know it's a negative divided by a negative, but I know that's going to be positive, so it's 4.75. And now I'm going to do option 1 again. We'll do some more option 2 later. But now our exponential is isolated. We can change this to log form. So this is going to be log base 4, this 4 right here, base 4 of 4.75 is equal to -4x. We can use the change of base here. I'll write it out. That's log of 4.75 over the log of 4 equals -4x. Let's figure out what those things are. So log of 4.75, close parentheses, divided by log of 4. I'm running out of room here, so we'll come up here. This is 1.1239. Actually, this rounds to 40 equals -4x. Now here's an example. I just told you a minute or so ago that you can get answers a little bit off because of rounding. So I did round here. I rounded this to 40. To get away from that, what I can do, instead of typing in 1.1240, I actually can just leave this value right here in. Instead of rounding, I'm just going to use this value. The way that I do that, I want to take it and divide it by -4. So I actually just hit the divided by sign. It's going to take the previous answer divided by -4 and gives me the answer right down here. X is equal to -2.810 because of rounding. So there's that answer. So the ones we didn't do, 26, 28, 27, and 30, will be similar to the ones we just worked through. And again, this was option 1. We'll get to look at other examples, option 2, a little later. 31, I only put one of them in here. It's actually very easy once you see what you're supposed to do. And we did go over these. If you have a logarithm with a base and then an argument, the part that you're taking the logarithm of is called the argument, equals the same base, then the arguments have to be equal to each other. So since it's log base 19 of something equals log base 19 of something else, those two things need to be equal. So we can just write 3m plus 10 equals -3m minus 2. And we solve this nice little, even a pre-algebra problem probably. So add 3m to both sides. That gives us 6m equals -2. We'll subtract 2 from or 10 from both sides. 6m equals -12. So m must be equal to -2. Now do recall when we go to solve something with a logarithm, we got a negative here. You can't take the logarithm of a negative. Now just because I got a negative doesn't mean this value is negative, because if we did -3 times -2, so putting -2 in here, minus 2, that's 6 minus 2, which is 4, and that is not negative. And so it does work out putting -2 in there. So that's how you do that section.